third method? The third method is gain measurement by three antenna methods. Three antenna methods. Okay, so three antenna gain measurement by three antenna methods. Okay, so what is this three antenna methods? Okay, so totally I'm going to take three antennas. Let us I'm going to take A1, A2, A3. I have taken three antennas. Let us consider antenna A1, antenna A2, antenna A3. Antenna A3. Okay. So let us take case one. In case one, in case one, so A1 is my transmitting antenna. In case one, A1 is my transmitting antenna, and A2 is my receiving antenna. A2 is my receiving antenna. Okay. So this is my case one. Okay. So which in case one, which antenna is transmitting antenna? A1 is transmitting antenna and A2 is receiving antenna. Okay. So in this case, let P1 is the transmitted power. Let P1 is the transmitted power and omega 1 is the received power. Okay. So A1 is the transmitted power of antenna A1 and omega 1 is the received power of antenna A2. Okay. Similarly, take case 2. In case 2. In case 2 also, A1 is transmitting antenna and A3 is receiving antenna. A3 is receiving antenna. Okay. So in this case, in this case also, the P1 is equal to P2. Okay. So that is here P1 or P2 is same, is nothing but amount of power transmitted by transmitting antenna A1. Since in this case 2, we have considered that A1 as transmitting antenna and A3 as receiving antenna. Okay, so what is this W2? W2 is the amount of power received by receiving antenna. The amount of power received by receiving antenna 3. Okay, so here we are considering that in case 2, A3 as receiving antenna. Okay, so the how much of amount of power that is collected by A3 is written as W2. Okay. Now let us take the case 3. Now let us take the case 3. Case 3, in case 3, here antenna A2 is transmitting antenna and antenna A3 is receiving antenna. Antenna A2 is transmitting antenna and antenna A3 is receiving antenna. So since A2 is receiving antenna, the P3 denotes in case 3, what is this P3 denotes? The amount of power radiated by antenna A2 and this is W3. Okay, what is this W3 denotes? The amount of power received by receiving antenna A3 because in case 3, A2 is act as transmitting antenna and A3 is acting as receiving antenna. Okay, now simply we can apply the Fields transmission equation. Okay, for case 1. So what are the Fields transmission equation says? Use the relationship between received power and transmitted power in terms of effective aperture. In terms of effective aperture. For example, let us take what is the expression for this one? So this is nothing but omega 1 by P1 is equal to AET into AER into lambda square into R square. Okay, so what is the expression for AET in terms of gain? AET is equal to G1 of, since that is transmitting antenna 1, G1 of lambda square by 4 pi. Similarly, what is the formula for AET? So you are writing is as G2 because this AER is receiving antenna. Which is our receiving antenna? A2. Okay, so G2 into lambda square by 4 pi into 1 by lambda square into R square. Lambda square will get cancelled. Okay, like this. Here, what is the expression you can write for case 2? Case 2 is what is the receiving power? W2. What is the transmitting power? Similarly, that is P2 or P1. P2 or okay, let us consider here. So here W2 or we can write it as P2 is equal to the expression is AET into AER by lambda square into R square. Here what is the expression here? Here what is the transmitting antenna? Transmitting antenna is G1. So that is G1 lambda square by 4 pi into what is the receiving antenna? G3. G3 lambda square by 4 pi to 1 by lambda square R square. Okay. So similarly here also we write the expression W3 by P3 is equal to same expression AET into AER by lambda square into R square. Okay. Here tell me what is the expression for here? Which one is the transmitting antenna here? Yeah, A2. So therefore we write G2 into lambda square by 4 pi into what is the receiving antenna? G3. So that is G3 into lambda square by 4 pi into 1 by lambda square R square lambda will get cancelled. Consider this is expression 1. Consider this is expression 2. Consider this is expression 3. Okay, so I will show here. So this is the first one. Okay, so this is the second one. Okay, so this is my first one. Okay, so this is my first expression. First expression means A1 is transmitting, A2 is receiving. Okay, by using Phillips transmission method, G1, G2 is equal to omega 1 P1 by 4 pi R by lambda whole square. What is this omega 1? Omega 1 is W1 is amount of power received by receiving antenna 2. P1 is amount of power transmitted by transmitting antenna 1. So totally have taken 3 antennas. Totally have taken 3 antennas. Okay, so this is the expression for the first case. Okay, so this is the expression for first case. Okay, so this is for first case. Next, this is the expression for second case. Okay, second case means what is the expression for second case here? A1 is transmitting antenna and A3 antenna A3 is receiving. Okay, so G1, G3 is equal to this. Okay, third case. What is the third case? A2 is transmitting antenna and A3 is receiving antenna. A2 is transmitting antenna and A3 is equal to this one. So this is expression 3. Okay, so the same expression 1. So this expression 1 can be written in terms of dBs as this expression 1 can be written in terms of dBs as so G1 plus G2 is equal to. So simply I'm applying a log on both sides or dBs. Okay, G1 by G2 is equal to 10 log based on W1 by P1 plus 20 log 4 pi R by lambda. So similarly for expression 2, for expression 2, okay, for expression 2, okay, so it is G1 plus G3 is equal to 10 log W2 by P2 plus 20 log 4 pi R by lambda. So this is for expecting P2. So this is for expression 1 expressed in dBs. This is expression 2 expressed in dBs. So knowing the values of omega 1, omega 2, omega W2, P2, P3, 3, lambda, and R, we can calculate the values of G1, G2, G3. Okay. So all these values, we can take summation or subtraction. G1, G2 is there, G1, G3 is there. You can take subtraction and different combination. From this, you can calculate what is the gain of antenna A1, what is the gain of antenna A2, what is the gain of antenna A3. Okay, like this, you can calculate like this. You can calculate the gain of the antennas by using the third method, that is gain measurement by 3 antenna method. So the basics for this is Friis transmission equation. Okay, you are writing this expression means this is because of Friis transmission equation. Friis transmission equation. So the what are the Friis transmission equation use? Use the relationship between received power to transmitted power in terms of this is transmitting, this is effective area of received by lambda square R square. Okay, so again, what is the formula for the AET effective aperture area? We know the formula, directivity or gain. Directivity or gain. G is equal to D is equal to What is the expression between directivity or gain? G is equal to directivity. D is equal to 4 pi E by lambda square. On this, what is the expression for AE? A is equal to G into lambda square by 4 pi. So in the place of AE, we can replace with G into lambda square by 4 pi. Okay. So depending upon the antenna, for example, if transmitting A1 is acting as transmitting antenna, we write it as G. If antenna A2 is acting as receiving antenna, then you write it as G2 lambda square by 4 pi. Okay, so similarly, if A2 is transmitting antenna and A3 is receiving antenna, how will you write this? Write it as G2 lambda square by 4 pi, and here it is G3 lambda square by 4 pi. Okay, so everything here, this comes from Friis transmission equation. Very, very important equation. Friis transmission equation. Friis transmission equation. Friis transmission equation. So this is how you can calculate the gain G1, G2, G3. Okay, so these are the things you want to keep in mind. Okay, so let us revise what we have discussed in this antenna measurement. So basic fundamental thing is you want to keep in mind the setup for radiation pattern. Radiation pattern. Once if you obtain the radiation pattern, so many parameters, by seeing that radiation pattern, you can calculate so many parameters. Okay. So what are the precautions? And transmitting antenna under test should be separated by a minimum distance of or should be greater than or equal to 2d square by lambda. And the entire setup should be kept in anionic chamber in order to get what is the use of this anionic chamber? In order to uh, uh, eliminate the effects of, in order to eliminate the effects of external electromagnetic interference. And the third one is the transmitting antenna gain should be more. For any antenna setup, this one is important. Okay, this one is important.